Hi, and welcome to this video on solving equations with variables on both sides. Okay, so in this video, we're going to look at solving equations with variables on both sides. But first, let's talk about what that means. Well, it's really simple. It means that you have an equation, as for instance in A, you have 9x minus 4 is equal to 2x plus 3. Well, all that means is that you have variables on both sides of your equal sign. So notice that you have an x and the 9x on the left side and a 2x on the right side. The same thing here. In question B, you have a 4r on the left side and you have a 12r on the right side. And then you have a 3r on the left side and a 4r on the right side. Okay, so let's talk about how to solve these. Well, there's three types of solutions that you could possibly have, okay? So when you have an equation with variables on both sides, you could have one of three types of the solutions. The first type that you could have is a one solution, and we'll talk about that, a many solutions or infinitely many solutions, and a no solution. So individually, we're going to solve these three problems to talk about what each one of those means, okay? So let's look at 9x minus 4 is equal to 2x plus 3. Well, how do I handle that? Well, if I have equations with variables on both sides, my goal is to get both of the variables on one side so that I can combine the like terms and to get both of the numbers on one side, okay? All right, so let's try that. When we look at this, 9x minus 4 is equal to 2x plus 3. It looks like for me that it's easier to move 2x to the left side, so I'm going to do that. Well, remember that in solving any equations, the way that you move a term is to subtract it and to create a zero pair. So in this case, I'm going to subtract 2x from the right side, and I'm also going to subtract it from the left side. So that is going to give me 7x minus 4 is equal to 3. Okay, because these canceled out into a 0. Okay, so now I'm going to move the negative 4. Well, since it's being subtracted, I'm going to add it to both sides, so plus 4. So that is going to give me 7x is equal to 7. Well, I'm not quite done. The goal of solving for the variable is to actually find out what the variable is equal to. So in that case, since 7 is being multiplied by x, I need to divide by 7. Divide by 7 on both sides. Therefore, x is equal to 1, okay? This is what we called a one solution. Why? Because we got one solution. What this tells us is that one number, that number being 1, will satisfy the equation. So let's make sure that it will satisfy the equation. I'm going to come down here and check. So I'm going to use x equals 1 and plug it into my original equation. So 9 times 1 minus 4 is equal to 2 times 1 plus 3. So if 1 satisfies the equation, I should get the same thing on both sides. So let's go ahead and simplify this. 9 minus 4 is 5, and 2 plus 3 is 5. And so yes, it satisfies the equation. Okay, so just a hint, this block here where it says one solution, only one solution will make your equation true. So it yields an answer such that you get a variable is equal to a number, such as n equals 5, t equals -1, m equals 0. Okay, so that's how you work an equation with variables on both sides. And if it has one solution, then that's what will happen when you try to solve it. Now let's look at some other types of equations. Let's look at B, okay? So what I'm going to do is when I look here, it looks like I have a lot going on. But the first thing I need to do before I can combine variables is I have to get them out of the bracket. So in order to do that, I'm going to have to distribute on both sides. Okay, so let's distribute. Remember, equations with variables on both sides can also be multi-step equations. Okay, so we have 8r plus 12 is equal to, well, what's 2/3 times 12? Well, 12 times 2 is 24, then divide by 3, and so that's going to be 8r. And then 2/3 times 18, well, that's 2 times 18 equals 36 divided by 3 is going to be plus 12. Okay, so you can see here that I end up getting the same thing on both sides, okay? Well, I have 8r plus 12 is equal to 8r plus 12. Well, in this case, what I have is really like two lines that are equal to each other, or when I have two equations that are equal to each other all the time, it's what we're going to call a many solutions. Let's see what tries to happen if I didn't recognize that these two are equal to each other and I continue working. So let's try to go ahead and combine the variables. Well, I'm going to say minus 8r because that one's positive, and move it over here because that one's positive, so that's going to cancel out, and this variable is also going to cancel out. So what I'm going to be left with is 12 equals 12. Well, 12 equals 12, it's an equation, but it's not one that I can solve for a variable, okay? And then if I even try to move 12, the only way I could move it is to subtract, right? So minus 12 minus 12. Well, I'm going to end up with 0 equals 0 on both sides. So notice that here my equation is equal on both sides, here my equation is equal on both sides, and here my equation is equal on both sides. The latter two, the variable is missing, but in the first one, the variable is still there. But what's going to happen when your equation has many solutions is if you continue solving, your variables will cancel out in the case of 8r minus 8r. So whatever your variables are, they will cancel out, but your equation will remain equal on both sides. So in that case, for a mini solution, any solution or number will make the equation true. So it yields an answer such as 0 equals 0, 5 equals 5, 2x plus 1 is equal to 2x plus 1. Okay, well, what does that mean that any solution will satisfy it? Well, many has infinite solutions. Okay, so that means your solutions go on forever. So any number that you plug in will actually work in your equation. So let's try some numbers. I'm going to try 1. So let's try 2 times 4 times 1 plus 6 is equal to 2/3 times 12 times 1 plus 18. Okay, so let's try that. Okay, so here I'm going to have 2 times 10 is equal to 4 times 1 is 4 plus 6, that becomes 10, if you're wondering how I got that. And this one is going to be 2/3 times, well, 12 plus 18 is going to be 30. And 2/3 of 30 is 20. 2 times 30 is 60, divided by 3 is 20. So 20 is equal to 20 on both sides. Now let's try another random number. Okay, so I know that 1 works. Let's try maybe 0 or -1. I'm going to try 0 because that's easy, right? So 2 times 4 times 0 plus 6 is equal to 2/3 times 12 times 0 plus 18. Okay, so these are just my checks. And this was a check over here. Okay, so I'm checking 2 different numbers just to show you that no matter what number I put in, it will work. And you can continue checking other numbers if you want. Okay, so this one, that will go to 0, so that will be 2 times 6. And this will go to 0, so that will be 2/3 times 18. Okay, so this will be 12, and 2 times 18 is 36, divided by 3. That will actually be 12, and so that one will work also. So 12 equals 12. So it's not the same thing. So when you check, it's not the same thing as a mini solution. So a lot of people get confused with that. Well, doesn't that mean that this one has many solutions too? Well, no, it doesn't. What it means is these are your checks, and your check should always be equal on both sides, but that's after you plug a value in. So there's no variable that you're trying to solve for in the case of the checks. But notice that in B, you were trying to solve for the variable, but what you ended up with was a true statement, which was an equation that's always equal on both sides. Okay? So remember that in your checks, you've already found your variable, so there's nothing so you're plugging something in, but when you're trying to solve and you end up with the same thing on both sides, that's different because you still haven't found a variable. But in the case of many solutions, any variable will work. So even if I wanted to try -12, if I wanted to calculate that, then all of those numbers would give me a solution. Okay, any number will give me a solution. Even 1.5, if I plugged it in here, would give me a solution. Okay, so now let's look at this particular this particular equation. So in this case, what I need to distribute so that I can combine like terms. So in this case, I have to distribute the -4. So I have 7 minus 3r is equal to r minus 8, and then it looks like minus 4r. So when I combine -4r, and r, I end up with -3r minus 8, or you could say -8 minus 3r, and 7 minus 3r. So in this case, when I try to solve for r, I'm going to add 3r to each side because I'm subtracting 3r. So plus 3r plus 3r, and my equation ends up being equal to 7 is equal to, those cancel, 7 is equal to -8. Well, this is untrue. This is not a true statement. Okay, so when I have an untrue statement, that means that no solution that I plug in will actually work. And so in this case, I end up with a no solution. So no solution, whenever you're trying to solve for the variable and your variables cancel, you end up with a statement that says 5 is equal to -3 or 0 equals 7, or in this case, 7 equals -8. Well, we know that that's not true, so this will be called a no solution. And so one way to show that is to write this big fat O with a line through it. Okay, I hope this video was helped, and you can watch it as many times as you need to go through the different types of examples so that you can recognize whether you have one solution, many solutions, or no solution at all. Okay, thank you. Bye-bye.